Hello, calculus students. So today we are beginning our first unit learning about topics in calculus, and the first unit in calculus is called limits. So limit is a word that you may have heard before in just the regular English language, but it is also a big topic in calculus. So that's our first unit. And this lesson in particular is going to focus on limit notation, so what is a limit, and then learning how to estimate limits from tables and graphs. That's what we'll be focusing on today. So for each lesson, I am going to want to start with a warm-up. Warm-ups have always been really important to me as a teacher, just because I think it helps get your brain going to prepare for the lesson. I don't know what you were doing before this, whether you were eating breakfast or watching YouTube or doing work for another class, but I want your brain to kind of get into the math mode. So it kind of brings in your prerequisite knowledge and then prepares you for whatever you're going to be learning later. In the classroom, obviously, all my students participate in the warm-up. Right now, you are going to have to hold yourself accountable for completing the warm-up. And I just want to note that you're enrolled in this class to learn calculus. Calculus is a really hard subject, and so my job is to make learning calculus as easy as possible for you. My job isn't to make learning calculus difficult for you. I want this to be as easy as possible for you. And one way I think to make it more easier and to help you in that is to participate in the warm-ups. So you will be doing these at your own pace. So take as much time as you want. I would say don't spend more than like 5 minutes on the warm-up. If you really get that stuck, it's okay to press play to hear my explanation, but I do want you to give it your best go. So at this point, you can go ahead and hit pause and take your time completing this warm-up. I'm going to assume that you just did that, and now I'm going to go over the warm-up. So the first problem, just asking what comes to mind when you think of the word limit. Maybe you have already learned a little bit of calculus, and so you know what a limit is in math. Maybe you've never heard of this as far as math goes, and you're not sure. I know some students, when they hear this word limit, they might think of like stopping point. Or I think some students even think of the word like enough, like that's my limit, that's enough. Basically, whatever you put, you're just kind of getting your brain going to think about what a limit is. So example, or problem 2 in the warm-up. Now here's some math. So given the graph of f of x, find the following function values. Hopefully we all know what this word means. But just in case you didn't, what this means is like a function value is the value of y at a given value of x. So we're given a value of x, that's all of these, all the things in the argument are x values. And then we need to figure out what is the y value that matches. So when x is 4, I'm going to highlight it. When x is at 4, the value of y is at 2. When x is at 4, the value of y is at 2. Easy. The next two just add a tiny bit of challenge. So when x is 6, I see that I have this open circle here at -1, but an open circle is not a function value. We need to go to where there's this closed circle down here. That's where the actual point is. The open circle means it kind of jumps over that pit, and our actual function value is down here at -3. I'll change the color of my highlighter so things don't get too hard to see. And then at x equals 2, again, there's kind of a little trick. I don't know whether to go up or down. The actual function value is at the point there at -1. There. So hopefully you were reminded of some things and this warm-up wasn't too stressful for you. All right, let's go on, learn about limits. So the problem 1 in the warm-up asked you what came to mind when you thought of what a limit is. Maybe some of you thought of the movie Mean Girls. I don't know if this movie is too old for you to have seen, but Katie in it was a mathlete, and she learned about limits in her high school class. But here's a definition of limits. So limits are a prediction or estimation of what we think the value will be at a certain point. So limits are a prediction or estimation of what we think the value will be at a certain point. You can pause this if you need to write down that definition. Remember, pause me whenever you need to, rewind me whenever you need to. That's the nice thing about this being a video, is if I talk too fast, you can slow me down. So I just put in a kind of real world example here. So here are my different heights in my different grades. So I said that in 10th grade, this would be like my 10th grade, I was 66 inches tall. So there's my unit. In 10th grade, I was 66 inches tall, and then I was 68 inches tall in 12th grade. I'm going to make this a little, there we go. I was 68 inches tall in 12th grade, and so then it's asking, how tall do you think I am in 11th grade? Okay, so we're making a prediction of what I think the value will be at a certain point. So the point in time that we're looking at, kind of like my x value, if you think back to the warm-up, my x value is the grade level, 10th, 11th, or 12th, and then how tall I am is the y value on the graph. So if I went from 66 inches to 68 inches, think in your heads, how tall do you think I was in 11th grade? You got the answer? Okay. I was probably, if we had to guess, if we had to give an estimation or prediction, I'm guessing a lot of you estimated that I was 67 inches tall. Okay? So this is what a limit is. It's predicting a value, a function value at a certain point. Another kind of real-world example would be maybe you're using your Chromebooks to watch a game, and the internet goes out for a second, or the video buffers, and you miss what happens directly at the 4-minute mark. So at this point, it's like, what happened? Well, you can look at what happened at 3 minutes and 58 seconds, 3 minutes and 59 seconds. You see he's making a shot on goal. Did the ball get past the goalie? Yes, it did. I can see at 4 minutes and 1 second and 4 minutes and 2 seconds, he made the goal. So your brain can kind of fill in what happened between there. So between the ball being right here and the ball being right there, your brain can kind of figure out what happened and make a prediction about what happened, even if you can't necessarily see what happened. Okay? So conceptually, this is all a limit is. Just estimating what's happening at a certain point. Obviously, we're going to have to bring a little bit more math into this to talk about graphs and tables. Okay? So estimate the value of a function f as x approaches 3. And I'm actually going to estimate the limit value of the function. Okay? Because we're not finding the actual function value. I guess I want to say that there's a difference. So what I did in the warm-up was finding the function value, which is what's happening at the point. A limit, is an approximation about what's going to happen near the point. Okay, so it's what happens when you get near the point. So I can see that at x equals 3, there's no function value. When x equals 3, there's no function value. But I want to know what's happening when you approach. So, I hope you all know this word approach. You can also just think of like gets close to. So as I get really close to 3, what is happening to the function? Because I can see at 3, it's undefined. There's a hole. So as I get really close to 3 from both the left and the right-hand side, I can see that my function value is getting close to 5. Okay, so I'm going to make a couple notes here. I keep hitting the space bar. Sorry. I know that f of 3 is undefined because there's a hole. There's nothing there. However, I know that the limit as x approaches 3 of my function f of x equals 5. So what this is saying is x gets close to 3, the function is getting close to 5. Okay. Let's look at this graphically. I kind of changed the directions a little bit. So estimate f as x approaches -1. So I can use that same notation. The limit as x approaches -1 of my function f of x. Well, let's look at what is f of x getting close to. This is where my -1 value would be, between -2.01 and -1.99. So this is where it would be. What is f of x getting close to? So between 4.99 and 5.01, it looks like it's getting really close to 5. Okay, so this is pretty much it. I do want to go over some notation. So here is just an explanation of the notation that I was just using. This just means the limit of, so the limit, and then of f of x, or of, some people are a little bit more formal and they might say of the function f. I don't care if you just say the limit of f of x. And then this is as x approaches 3. Okay? And so there are a couple ways you can say this. Will you please repeat after me? So we could say it as the limit of the function f as x approaches 3. There you go. You got to practice. Okay, cool. So the limit of f of the function f as x approaches 3, or the other way we could say it, we could change the order. Repeat after me. We could also say the limit as x approaches 3 of the function f. Repeat after me. The limit as x approaches 3 of the function f. Okay? So these two, basically, you can say in either order. It's kind of whichever way you prefer. Okay? One other thing about limit notation. You can find the limit from just the left or the right side as well. So this notation here, as I approach, as x approaches 3, the assumption, or what I know, is that it's as x approaches 3, and I'm gonna just write parenthetically, from the left and right hand sides. Okay, so this is from the left and the right hand side. If I just say x is approaching 3, I know that I'm meaning from both sides. Ooh, I didn't mean to do that. So going back to our graph, you can say, I said the limit as x approaches 3, I'm looking from both the left and the right hand side. You can see the arrows I drew came from both the left and the right hand side. And then same thing here, if I was looking at the limit as x approaches -1, I did look from both the left and the right hand side. So the left just means numbers smaller. So left means the number smaller, and then the right hand side means bigger numbers. Okay? I can, however, choose to look from just the left or the right. Okay? And that's where these little pluses and minuses come in. So we're just gonna write our definitions here as well. So this is the limit of f as x approaches 3 from the left. So the little minus sign means numbers less than 3. And so numbers less than 3 means approaching from the left. And then here, this notation means the limit. I'll do it in the other order this time. So the limit as x approaches 3 from the right. So the plus sign means numbers bigger than 3, so that means approaching from the right. And then of f. So notice that I kind of said them in the different order. I will continue to do that throughout this course. You can say it in whichever order you prefer. Okay? And then at the bottom there is this important note. In order for a limit to exist, the left and the right hand limits must be the same. So I'm going to go back to these examples. Since the limit from the left and the right in the graph in the table, we're both going to the same point. So from this left-hand side, the limit as x approaches 3 from the left equaled 5, and the limit as x approached 3 from the right equaled 5, then I can say this. The limit as x approaches 3 in general of f of x equals 5. Okay, let's look at some examples where that's not necessarily true. So sometimes the limit is DNE, and DNE means does not exist. Pardon me, I need a sip. So sometimes the limit does not exist. And so, going back to this definition, in order for a limit to exist, the left and the right hand limits must be equal. And so, what's going to make a limit DNE? Let's expand upon this idea. Come on. Whatever. Okay. A limit does not exist if the limit as x, I'm going to make my notation a little better. Sorry. Yeah, I need better notation. So I will say the limit as x approaches a of f of x. Let's use our notation. So the limit as x approaches a of f of x does not exist if the limit as x approaches a from the left of f of x does not equal the limit as x approaches a from the right of f of x. Yeah, that's better. So that's a formal definition. So looking at this graph, some of you might be thinking like, oh, well, I don't think the limit exists at these little holes, just because they look kind of weird. However, the limits actually do exist there. So let's use this one over here, for example. Okay, let's look at the limit as x approaches 7 from the left. So from the left, the limit as x approaches 7 from the left is going to 4. And then the limit as x approaches 7 from the right of f of x, so this way, it's also going to 4. So even though there's that weird hole there, they're still going to the same point. So because these two things are true, I can just say the limit as x approaches 7 of f of x equals 4. Okay, so where does it not exist? There's another place where the limit looks a little weird. You're probably with me saying it looks weird right here at 3. Okay, so let's do that same process. Let's go here. The limit as x approaches 3 from the left of f of x. So from the left, the limit is going to 3, and the limit as x approaches 3 from the right of f of x. So from the right, as x approaches 3, the limit is going to 6. So 3 and 6 are not equal, so the limit as x approaches 3 from the left and the right are not equal to each other, which in sum will tell us that the limit as x approaches 3 of f of x does not exist. And that's the only spot on this graph that I can see where it does not exist. So this would kind of be my final answer. Then let's look at this graphically, in a table. So here I can see my function values are really close to each other, but then at this point right here, so this would be about where x equals 5.0 it looks like, I can see the function value has a jump, similar to how in the graph there was, this is called a jump. The graph jumped from one value to the other. Same thing is happening here at 5. So it jumps from 4.99 to negative 1.01. So I can say the limit as x approaches 4 from the left of f of x does not equal the limit as x approaches 4 from the right. Therefore, these 3 little dots mean therefore. I don't know if you've learned that in science. Therefore, the limit as x approaches 4 of f of x does not exist. Okay. So in this little lesson, we learned the definition of a limit. Definition of a limit in general, and then how to find the limit from a table and a graph. A little bit about limit notation, and then an example of when the limit does not exist. We used a lot of notation, by the way. You should look at your notes and be like, dang, I've already learned so much. If you had looked at this like before our lesson, you wouldn't have understood what this meant. It's just a lot of new notation, so good job for sticking with me through this. I hope you feel like you're pretty smart. So in the next video, and if you're not, if you're like, I'm still a little lost, in the next video I'm going to go over some examples. So I'm going to end this one for now. The next video will have a lot of examples which I hope clarify this for you.